All right, let's do some SAT problems. So what we're going to do is I've got all these SAT problems organized by type. So we're just going to go through every single type. And these are all the ones that are solved for X, where I just feel like they're just asking you to solve for X in reality. So I think a big thing with the SAT is timing. So when you have a question that you can do quickly, you've got to be able to do it quickly. So we're going to do ones like this quickly. Even do them in our head if you can. So what is this saying? This is saying that K equals 3. So they're saying that this right here is 3. And so how do you now get X by itself? Well, you just got to multiply by the 3. You got to add the 1. So 3 times 3 is 9. 9 plus 1 is 10. That's the answer. And so let's go to this one next. So what is this one going to be? If y equals k times x, where k is a constant, and y equals 24, when x equals 6, what is the value of y when x equals 5? So I think this is a really important idea. They have you do stuff like this a lot. So see what they're doing here is they give you this equation. It's got 3 variables. And then they tell you what 2 of the variables are. So think about that. That lets you solve for the last variable, right? And then once you know the last variable, then you know the whole equation. You can just plug in 5 and find what y is going to be. So that's what we're going to do. We're going to go y is 24. So 24 equals k, and then x is 6, k times 6. So now we divide both sides by 6, k equals 4. And then now we know our equation is just y equals 4 times x. So now if they're asking us when x equals 5, well, we know that y equals 4 times 5. So y equals 20. And there we go. So this problem is interesting because like many SAT problems, there's kind of a shortcut way and there's kind of the real long way. So let's kind of do the real long way first. So what's the real long way? Well, we can do it just like we did the last one because you see it's the same way. They give us the x value and they give us the y value. We can go find the a value. So we can say that a times 4 squared plus 24 gets us 8. So then we can solve for a. So to solve for a, we're going to subtract 24 from both sides. So that's negative 16. And then 4 squared is 16. So then when we divide by 16, we see that a is negative 1. And so what is the equation we're actually working with here? Just negative x squared plus 24. So then we say, well, now if we know the whole equation, we can just plug in negative 4. And so what happens when we plug in negative 4? Well, negative 4 squared plus 24. Well, negative 4 squared is positive 16, but then it's multiplied by a negative, so it's negative 16 plus 24, which is 8. And so that's the answer. But do you see the short way? It's a little obvious, or it's a little more apparent, I should say, once we've solved this. Look at what we're doing. We're plugging in a positive 4 and a negative 4, and all we're doing to it is squaring it. So whether we plug in a positive 4 or a negative 4, it doesn't matter. We're going to get the same thing because either way, right away, we're going to get a positive 16. So without doing any work whatsoever, once we see that all we're doing here is squaring the x, we know that plugging in a 4 and a negative 4 is no different. We're still just going to get 8. So that's a cool problem. That shows some of the shortcuts the SAT offers sometimes. Now, one like this, you just got to think about it, I guess. For what value of n is the absolute value of n minus 1 plus 1 equals 0? And so you think about absolute value. What's the absolute value? What does the absolute value mean? That means the output is always positive or 0. But so think if you have this, the smallest this number can be is 0. But then we're going to immediately add 1 to it. So is it ever going to be equal to 0? No, this is never going to be equal to 0. The absolute value is always positive or 0. So if you add 1 to it, there's nothing that's going to make that equal to 0. All right, so what's going on here? If t is greater than 0 and t squared minus 4 is equal to 0, what is the value of t? Well, you just got to solve for t. That's easy enough. So we're going to add 4 to both sides, and then we're going to square root both sides. So t is plus or minus 2. Don't forget that plus or minus. But then in this question, it doesn't even matter so much because they tell you that t is greater than 0. So that does mean we're rejecting this negative answer and only keeping the answer that is greater than 0. And so t equals 2. All right, what's the next one? So here we got to know the volume of a cylinder. And they do tell you the volume of a cylinder on the front of the SAT. But you really ought to know it anyway. Because what is the volume of any shape like this? Well, conceptualize it as you're going to take that area on the bottom and you're going to layer it up as you go higher. So what does that really mean? That means you're taking the area of that circle on the bottom. So what's the area of a circle? That's pi r squared. And then you're multiplying it by the height of the cylinder. Right? Because you're going to layer it up how high the cylinder is. So then you're going to multiply by h. And that gets you the volume of a cylinder. And again, they do have that formula just right on the front of the SAT. But now that we know the volume formula for the volume of a cylinder, we can just plug this into the formula and say that 72 pi is equal to pi r squared times the height, which they tell us is 8. And now all we have to do is solve for r squared. So how do you solve for r squared now? We just got to divide by pi, divide by 8. So we get that 9 equals r squared. And now we square root both sides. And I would do plus or minus, but we're talking about length here. So we can't really have a negative length. But there we go. R equals 3. And is that our answer? No, it is not. Because another thing you've always got to be checking on the SAT is what is the actual question? They're asking for the diameter here. So there was no good way to solve for the diameter directly. But now that we have the radius, we can know that the diameter is just double that. The diameter is 6. So make sure you're watching for that. They got no sympathy if you answer 3 to that question. Even though if you answered 3, you did the entire thing correctly. They got no sympathy for you. You've got to realize they're asking for the diameter, so you need to answer 6. So here's another question. So I think one big thing about the SAT, I was just talking about while we were paused, is that it's a lot about knowing what to read and what you don't need to read. So like here, if I just see number 9, like there's a number 10, so maybe we have to go back and read. But if I just see number 9, I just look at these answer choices. And that's another thing. You always got to look at the answer choices first before you even start doing anything. Because all the answer choices tell you what to do. They tell you you're trying to get t by itself. So then you just come up here and look for the equation that has t in it and just get t by itself. And so that's as simple as subtracting that to the other side and then dividing by 1.08. So t equals a minus 1052 divided by 1.08. A. Didn't need to read any of that. And then now maybe when we get to 10 we have to read it. But so at which of the following air temperatures will the speed of sound be closest to 1,000? So there you just have to pick out what you have. So you have that the speed of sound is equal to 1,000. And we want to know the air temperature. So we'd hope that those are from the equation. So then maybe we come up to here, come up to our little paragraph, and we look at what everything equals. So they very often write it like this. See how they say A, the speed of the sound wave? So what did we say? We said the speed of the sound wave was 1,000. So we're doing that A equals 1,000. And we want to know the air temperature. We want to know the T. So now that we have this equation that we found, that's as simple as plugging in 1,000. So we have 1,000 minus 1,052 divided by 1.08. And this is definitely a calculator problem for the SAT. They're not making you do ridiculous stuff like that. You just whip out the numworks real quick. You do 52 divided by 1.08. And you get negative 48 degrees. I guess we should make sure we didn't round at 48.1. So negative 48 degrees. There we go. And see, so you don't even really need to read much of that paragraph. You can just know what you're looking for. And that's often what you're looking for. You got to say, what variables do we have? And like, what do they equal? And then you know to come up into the paragraph and look for what both of those variables equal. But I think it's easier to see once you like already know what you're trying to do with it. All right, let's move on. So one thing we'll notice about these packets is that they're made by a human being, me, which means there's some mistakes. So that's okay. We'll just skip those. So then we get to one like this. And this is another kind of fun one that the SAT, like, they kind of like throw you a bone a little bit if you want to do some interesting stuff. So let's do it the slower way and let's do it the quicker way. So, I mean, the slower way is pretty straightforward, right? We just need to solve this for x. So subtract 6 and divide by 5. So we get that x is 4 over 5. And then, now that we know that x is 4 over 5, we just put that into here. So we do 10 times 4 over 5 plus 3. And just simplify that out. I will say, you should never, in this case, do the 10 times the 4. I hope you would never do that. You need to cancel out the 5 and leave this as a 2. So you're left with 2 times 4, which is 8, plus 3. So 11 should be your answer. But what's the fun way? What's the quick way to do this? The quick way to do this, and this happens sometimes, it's not that much quicker, but it's definitely cooler, is to just think about what you have. Right now you have 5x plus 6. And think about how you can build this thing that you want, this 10x plus 3. So what you could do, remember you can always do things to both sides of the equation. So I can multiply both sides of the equation by 2. Make this 10x plus 12 equals 20. And then I just say, what else do I need to do? Well, I have the 10x. I just have to make that a plus 3. Right now I have a plus 12. So I've just got to subtract 9 from both sides. And then look at what you get. You get 10x plus 3 equals 11. So you just go directly to your answer. We never even found out what x was. We didn't need to. Because we just started with what they told us and then built this new thing. All right, on to the next one. This looks like... What are they saying here? So here's another thing. If they tell you that, like, if they give you inequalities, normally you ignore the inequalities. Because the only reason they normally give you inequalities is to just make sure you don't get imaginary numbers here. So I do imagine that that's the only reason they're telling you something like that. So it might come into play, but probably not. Looks like all we have to do, so x is 7, so we can put in a 7 for x. And then they just want us to, solve for k. So maybe that'll come in when we pick which answer we choose, because of course we expect 2 answers, because it's squared. But let's see, we want to solve for k. So we're definitely just going to add the 7 to the other side, and then square. So 2k squared plus 17 equals 49. And then what are we going to do? Probably just try to get the k squared by itself. So let's subtract the 17 and then divide by 2. So 49 minus 17 is 32. 32 divided by 2 is 16. So k squared equals 16. Square root both sides. So k equals, of course, plus or minus 4. But that's, see, where this comes into play. We reject the negative 4. We just choose the positive 4. But that's like a natural-ish thing to do anyway. A lot of the times people just forget the plus or minus in the first place. But yeah, that's what that is. All right, let's keep going. So this is a good one. This is a good one. What is the sum of all the values of m? So I'll tell you right now, there's a shortcut that we can do that just lets me tell you right away that the answer is 8 without doing any math at all. Do you know that shortcut? I know that shortcut. So what is the shortcut? The shortcut is that if you want the sum of all the solutions, you simply take this number right here and divide it by the number in front. We simply say, and then you change the sign, actually. So we simply say that the sum of the solutions is negative b over a. And you can think about why that is because of like factoring and stuff. You can also think that, mainly factoring. Mainly factoring. That when you try to get this middle number, you're trying to think about what adds to get the middle number. So that's the sum. And similarly, you're trying to think about what multiplies to get this last number. So if they ask for the product, that's just C over A. And you don't have the opposite sign thing. The opposite sign thing just comes from, like how there's always opposite sign things. When you get x minus 2, that means it's positive 2. So this is how you quickly get the sum of the solutions. This is how you quickly get the product of solutions. And so if they ask for something like that, that's how you do that problem. You don't get the solutions and then find the sum of them. You just do that, because often the sum, they're going to involve square roots. I bet the solutions involve square roots. And you can't be dealing with that when you have a trick that's this nice and easy. All right. Let's move on. So what is this? In the xy plane, the point 36 lies on the graph of the function that. What is the value of b? Oh, well, this is another one of those classics. They give you the two variables, the 3 and the 6. And so then we have to find the last variable. So x equals 3, y equals 6. Remember f of x. That's always your y. So that's what 6 is. We're going to have 6 equals 3 times 3 squared. So I'm going to go ahead and do that out. That's 27 minus 3 times b plus 12. So I think it's going to be easier in my head. I'm going to add the 3b to that side and then subtract the 6. So 27 plus 12 is 39 minus 6 is 33. And that actually works out nice, because then you can divide by 3 and get that b is 11. And that's a little scary because there's no answer, but that has to be true. All right, cool. So this is another one like that x one, although it's easy enough to do it the other way. So what's the slow way? You divide by 3, you get r equals 6. You plug that in here, 6 times 6 plus 3. So the answer is 39. Obviously easy enough. The cool way to do it is to divide by 2, or to multiply by 2 to get your 6r, and then add the 3. So then we just immediately get that 6r plus 3 is equal to 18 times 2, 36, plus the 3, 39. And so I know that probably seemed like the same method, because it kind of was, but it was thinking about, instead of solving for r by itself, actually finding what r was, you just turn what you already have into what you want. Which is pretty cool. And here you might want to do something like that, but we still got to get x out of it. Like, for example, another super important tip. If you have a fraction equals a fraction, a valid thing to do is flip over both fractions, because you're doing it to both sides. So it's totally legal and truthful to say that x over 5 equals x plus 20 over 15, but that's not very helpful, because we want the number value of x over 5. So we have to solve for x. And how do you solve for x in something like this? Well, what you do, we didn't even need to flip over the fractions first. We're just going to cross multiply. So we're going to have 15 times x, 15x, equals 5 times x plus 20. So I'll go ahead and distribute 5x plus 100. And then to solve for x, it's as simple as subtracting 5x and then dividing by 10. So we get that x equals 10. But now, because the SAT is dirty, they just want you to get questions wrong. They're not asking for x, yet they put the value for x in there. That is not testing for math. That is testing for following directions, which I guess is important in college. Because what they want is x over 5. So now that we got what x is, we have to divide that by 5. So the answer is C. Brutal College Board. I mean, nobody said the College Board was nice. Everyone knows what the College Board is up to. And it's not good things. All right. So now we want the solutions to this equation. So definitely what we should do first, and we should always be on the lookout for stuff like this, is what can we divide everything by? We can divide everything by 3. So that's what we need to do, is we needed to first off divide everything, even the 0, I guess, by 3. Because then we get x squared plus 4x plus 2 equals 0. And so that wasn't necessary, but that definitely makes things easier. Because now if we're able to factor it, it's going to be easier to see. Now we still can't factor it, but that also is going to make it easier to do the quadratic formula. So let's do the quadratic formula. So what is the quadratic formula? You have to have that memorized for the SAT. You really do. But we should all have it. It's negative b plus or minus the square root of b squared minus 4ac all over 2a. And so we just plug that in. Negative 4 plus or minus the square root of 16 minus 8 over 2. And then we simplify. So negative 4 plus or minus, let's see, the square root of 16 minus 8. So 16 minus 8 is 8. The square root of 8 is 2 root 2. So plus or minus 2 root 2 over 2. And then now, even better, look at how there's a 2 in both of those numbers. So I can actually just cancel both of those out. Negative 4 divided by 2 is negative 2. 2 root 2 divided by 2 is just root 2. And there we go. Hopefully that's an answer. It is. A. All right, so what is one possible solution to this equation? Again, like the other one, they say that. We're going to ignore that to the end. So let's solve for x. We just want to find one possible solution, but we're just going to have to solve for x. So, well, first off, we should see there's an x on both sides. So let's go ahead and divide both sides by x. They do tell us, I guess it does matter here a little bit, that x is greater than 0. So we are allowed to do that because x is not equal to 0. And we don't care about that solution. So then we just have x squared times x squared minus 5 equals negative 4. And from there, I do think we're going to have to distribute. We're going to have to distribute that x squared. So x to the 4th minus 5x squared. And then we're going to add that 4 to the other side. And the whole point of that is that now we're going to be able to factor. We can do the idea where I like to call it like a substitution, where we say we're going to say that x squared is equal to a. Because what this is right here, x to the 4th, is x squared squared. So then what this is a squared. And then that allows us to look at our equation like this. And now it's like we can just factor this like it was just an x. So that's a minus 1, a minus 4. And then once you get here, I think this is the good step to say, well, it's not a that we want, it's x squared that we want. So let's go back and put the x squareds instead of a, because then we have x squared minus 1 and x squared minus 4 equals 0. And now you just got to keep factoring. People always forget this, but x squared minus 1, that factors. That's the difference of two squares. That's the most important factoring pattern. X squared minus 1 is x plus 1, x minus 1. Just the same, x squared minus 4 is x plus 2, x minus 2. Just the square root of those numbers. And so now what are all of the solutions here? Well, if we want to be thorough, since we divided by x equals 0 is a solution. But then we also have negative 1, positive 1, negative 2, and positive 2. So you can't grid negative answers anyway. So that's why, it's another reason why they want x to be positive. So the only answers we have are 1 or 2. So don't get caught up about choosing one. That's why they say one possible solution. There's just multiple answers. There's very often multiple answers on the fill-in-the-blank ones. All right, let's continue on. It got a little wild there, covered up the question, but that's okay. So if 7 over 9x minus 4 over 9x equals 1 over 4 plus 5 over 12, what is the value of x? So like me personally, I would just combine these fractions. I would just say we already have a common denominator here. 7 ninths minus 4 ninths is just 7 minus 4 is 3 ninths times x. And then here, 1/4 to get the common denominator, you just got to multiply the top and bottom by 3. So that's 3 twelfths. 3 twelfths plus 5 twelfths is 8/12. And then from there, I just simplify. So this is 1/3. So this is x over 3 equals, cancel out the 4's, 2 over 3. Well, that lets you see it right there, right? X equals 2. Yeah, I don't know why I'm so unconfident in that, but no, that's definitely right. I suppose if we wanted to, we could plug it in. Well, if we plugged it in, we'd have to do all this same math anyway. But yeah, so what do we do? We said 7 minus 4 is 3/9. We combine that to get 8/12. We simplified 8/12 by dividing them both by 4 to make that 2/3. Cancel out the 3 to make that 1/3. And then multiply both sides by 3. X equals 2. Beautiful, beautiful. All right, we got 2 more for tonight. So, number 7. So we were just talking about the grid in answers and how when you grid in an answer, you only have 4 slots to grid in the answer. So if you have fractions, like here, all 3 of these answers should be acceptable because they're all equal to the same thing. But if you extended this to be like 24 over 16, that's equal to the same thing, but you're not able to grid that because when you try to grid it, you have to put it in like this with a slash to show the fraction, and see how that's 5 symbols now. And you can't grid 5 symbols. You can only grid 4 symbols on the SAT. So you'd have to simplify it at least to that, but you could leave it at that. All right, so now we got 2 more. So what is the value of W? Well, I would just cross multiply. Maybe not even cross multiply. I'd multiply the 5 on the top there, the 3 on the bottom there. So that's just 5 times 4 over 3 times 3. That's just 20 over 9. Don't need to spend any more time on that problem. And then which of the following expressions is equal to 0 for some value of x? This is just like the one we did before, except for a little different. You just kind of look for the odd one out, just like the one before, because all of these are positive, right? The absolute value is just always positive. It doesn't matter if it's a negative x on the inside. It's just always positive. And so when you add 1 to it, it's going to be even more positive. The only way it's going to get to be 0 is if you subtract 1 from it. And that's good for today. This video has gone on quite a while, 27 minutes already. So I think I'll leave you with that. But we'll be hitting you. We'll come back tomorrow and finish this up. That'll be the idea.